Good morning everyone, my name is Vaibhav and I'm from team Dyrotics. So today I'm gonna show you all the technical aspect of our robot. So our robot name is Biros, which came from the Biospire robotic snake. It's heavily inspired from the snake because snake are so flexible and they can easily traverse through small holes and cracks. So that's why we choose this design. So now just move into the design of a robot. So basically this robot is made up of small segments, small structure basically, and each segments have its own actuator or a servo motor. So we can individually control all the segment itself. But to controlling this whole robot, we created a mathematical model. So as you can see on the screen, that it's shaped like a curve basically. So we don't actually give the individual servo motors to where it has to move. We actually just give the diameter of a curve, and inverse kinematic model just calculate all the motor joints where it has to move to create an arc. So now let's move on to the how we control the model, how we gonna move it. So as I told you, we are using something called inverse kinematics model. So by using that models, we gonna create an algorithms to control the motion of a robot. I can show you some example of this. Firstly, basically we created a sine wave function, moving algorithm. So it's using sine waves to traverse forward, as you can see in the video. And next motion we are working on is called side sliding motion. So robot don't basically have to turn around, it can just side slide into the left right direction. And next is turning motion, it can turn right or left, as you can see in the video. So now let's move on to the next thing, which is crack and hole detection. How it gonna detect the crack and hole? As you can see in the video, it's trying to detect the dimension of a hole where it has to go, and then it's gonna mark the center point. And once we get the center point, we're gonna just trace backwards to get all the dimension of the structure that we are gonna into traverse. Now moving on to the next thing, which is depth camera sensing. So as you can see in the front of our robot, there is a camera and there is also a LiDAR sensor. So we are using machine learning model to combine those two data and get the 3D depth of what it sees basically. I can show you one demo of this also. You can, as you can see in the video, it's combining actually both of the data and try to get the depth of what it's seeing basically. So all the bright parts you are seeing is the object closer to the image or the camera, and all the dark spots are the depth basically of the object further from the camera. Once we get the depth of what it's seeing, then we gonna calculate what the next step it has to take. So once we get the dimension of object which we're gonna traverse through it, then the inverse kinematic model gonna decide how it's gonna move into the hole or crack. Now let's move on to the most important thing, which is how this robot's gonna traverse through hole or a crack. So as you can see, there are 4 sensors in all 4 sides of a robot, and there is a sensor in the front and there was a camera. So what these 4 sensors are gonna do, just imagine there is a cave. Okay, there is a cave, and firstly the head moves inside the cave. Head's gonna collect all the data of the ceilings basically. Then all the bodies gonna traverse into the crack, and head's gonna at the same time head's gonna collect all the data of the ceilings. So once it's done the collecting all the data, it's have what is called the 3D depth map of a crack or a hole or a tube. Once we get the dimension of crack from inside, then because it's so flexible, it's gonna just reshape accordingly to the dimension of a crack. So once it just adapt itself to the dimension of a crack, then it's gonna just easily traverse through the crack itself and the hole. Once inverse kinematic model decide what it has to do the next, then it gonna send those information to the pre-built algorithms, and then that algorithm just decides to move forward, backward, left or right in the tube. So now if you're having a doubt that this robot is so big, how it's gonna going to any crack and hole, so I'm gonna tell you that this is just a prototype. We have to just test that this idea is working or not. In reality, we're gonna just make this robot much smaller basically, and we're gonna create this from stainless steel, or all the bodies from the stainless steel. And thank you for giving us this opportunity. We actually learn a lot of things by doing this project, and I hope you guys like our project and our work.